Yan. So hi, my name is Juan Andre V. Perez, and I am with Anton Gabriel Shison, and this is Group 14. This is the source code of our M2 project for IT154. So if you open the source code, first you will see the job list. So this contains a structure of the job list, which you will be able to see later in the output. So if you go further down, you will see here, here's the starting screen. And here contains the code asking you to input the memory size, storage compaction time, and coalescing time. So if we are to go down further, compaction, here's the code of the compaction. Compaction uses the technique where you combine all the fragmented holes in the job and pushes the job upward in our visualization, which you will see later. And the coalescing time is the uses of technique of merging two adjacent holes into a singular larger hole. And here is the allocation code, allocation module. This is the procedure where it asks for data access. Okay, so next, Anton will be showing you the output of our source code.
And run it. So, okay. So let's try to expand it. Okay, so the program will first ask you for your memory size. So our memory size, for example, is 1000. And then we'll hit enter. Now it will ask you for the storage compaction time for your simulation. Okay, so our storage compaction time in our example right now will be 20. And then it will ask now for the coalescing time. So we'll just put 1 for our simulation right now. So as I hit enter there, we'll be moved to the second screen, which will now ask for the number of jobs. So for our example, we'll just input 7. And then for job 1, it has the size of 500. And then has the time unit of 3. For job 2, it will have the size of 250. And then a time unit of 4. Now for job 3, it will have the size of 200. And then the time unit of 5. Now for job 4, it will have the size of 350 and the time unit of 3. Now for job 5, it will have the size of 60 and then a time unit of 5. Now for job 6, we will have 300 as its size and then a time unit is 3. Now for job 7, the last job, will have 400 for its size and then 2 for its time unit. So here in the next screen, you will see that we will see the compaction time we've entered earlier, which is 20, and then the coalescing time, which is 1. And then right now in our memory layout, you could see that its job is now at the current time of has the current time of 1, and the status right now is processing job 1. So we'll just hit enter. Okay, as you can see, it added the job 2, which is 250 kilobytes. And if you noticed at the list of jobs, it's subtracted by 1 with our given earlier. So we'll just hit enter and it will process job 3 next. Add in the memory layout the job 3 and then subtract the time unit by 1 of job 3 and then we'll hit enter again. Now we are at time 5 and our status is processing job 2. So we're at job 2. We subtracted 1 in its time unit. We'll hit enter again. Now we are we are in time 6. Processing job 3. We have subtracted its time unit again by 1. Now hit enter again. We are at job 7. you could see that we are processing job 1, and in the list of jobs, its status is done. So in here at time 7, we completed the job 1. That's why you can see in the memory layout that it has a whole of 500 because we have deleted the job since it's finished already. So we'll hit enter again. Now, since we have a spare space, we added in job 4, which has 350 kilobytes. So its time unit will be subtracted by 1, just like what happened earlier with the other jobs. And then we'll hit enter again. Now, job 5 has 60 kilobytes only. That's why we can insert it in the memory layout. Okay. Then its time unit is also subtracted again by 1. And then we'll hit enter again. Now we are at time 10 and currently processing job 2. Okay. So job 2's time unit is subtracted by 1 again. Now we'll hit enter. Then for processing job 3, we have subtracted again the time unit of job 3 by 1. So hit enter again. We're at job 12. So in job 12, we're processing job 4. So we have subtracted the time unit of job 4 by 1 again. And then we'll hit enter again. We are at job 5. So in job 5, we have subtracted yet again the time unit by 1. And then hit enter again. You can see that since the time unit of job 2 was 1 earlier, it is now 0 right now because uh, we're now gonna process job 2, and then when we process job 2, we have completed its process. Okay, that's why as we completed its process, we have removed it in the memory layout. Okay, so it will leave a whole of 90 kilobytes and 250 kilobytes. Now, since we have two adjacent holes there, in our next time, when we hit enter, you can see that the two holes coalesce. So it has a hole of 340 right now. So we hit enter again. We're at time 16 right now. In time 16, we're gonna process job 6. Okay. Job 6, time unit is subtracted by 1. And then when we hit enter again, we're now at job 3. So job 3's time unit is subtracted by 1 again. Then let's hit enter. So as we hit enter, we're processing job 4. And as you can see, the process of job 4 is now done in its status. So there. You can no longer see in the memory job 4 since its status is now done. So it will leave a hole of 350 in the memory layout. Now moving on, let's hit enter again. We're gonna process job 5. So job 5's time unit is subtracted by 1. Then let's hit enter again. Job 6, we're now processing job 6. And currently we are in the time 20. So earlier we have set the compaction time in 20. That is why in the next time, we will now compact all the processes or job in the memory. So when we hit enter, it will proceed to compacting. So let's hit enter until time 23. Okay, there. You could see that the memory layout has compacted the jobs in there. So you can see that there are two holes underneath. So let's hit enter again. So still compacting. And then there, now we are at time 25. Now processing job 3. So our job 3 is now done. So you can no longer see job 3 on the memory layout. So let's go on. Job 7 -1 on the time unit. Okay, and then enter again. Let's hit enter again. And then there you can see that one process is done again. So job 6 is concluded. And hit enter again. Now you can see that it's coalescing the two adjacent holes earlier. So you can see that there is a 500 kilobyte now, 5 kilobyte hole in the memory layout. So let's hit enter again. Next is process 7, processing job 7. Hit enter again. It will now coalesce the two memory spaces. So there, let's hit enter again. And then the job is finished. We have 32 time units in our simulation. And that's the output of our source code.
Okay po.
Thank you for watching.
Thank you po.
Okay, so let's try again. Let's try to run the program with the same memory size, which is 1000. And then for the storage compaction time, earlier we did 20. Now let's try to make it 30. And then as for the coalescing time, let's make it 3. 3. Okay. So the number of jobs is 7 again. Then job 1 has 500. Time unit 3, 250 on the second job. And then 4 for its time unit. And then job 3 has 200. And then for its time unit, it's 5. And then for job 4, it has 350. Time unit of 3. And then job 5, it has 60. And then 5 for its time unit. Now for job 6, it has 303. 300, sorry. And then for its time unit, it's 3. Okay. And then job 7, 400. And then for its time unit, it's 2. Okay, so let's try and hit enter slowly. So let's run it slowly. Enter again. Enter again. We can know, enter again. Enter. 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 Okay, it's coalescing like in the same current time period on our first example. Okay, so let's hit enter again. Enter, 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 enter. Okay, coalescing again in 22. So enter, enter, enter. Okay, and then so we're now in 26, coalescing. Okay, 26 coalescing. Okay, so you'll notice that we had already 3 coalescing periods in our time. Okay, so let's hit enter. Enter, coalescing. Okay, so at time 30, we are done with our processes. So for our second example, we finished at 30 time units. So based on what I observed, when if we were to compare our coalescent time from the first example to the second example, we had a lot more coalescing time on the second example. And then for its compaction time, we didn't reach the current time 30, which is the one we set earlier. So we didn't see any compaction time on our algorithm in the second example since we inputted a big one. Okay. So as for its final result, the result was it was faster. Earlier it was 32 time units, now it's 30 time units. So I think that is all that I noticed in the comparison of the two examples. Uh, Again, my name is Anton Gabriel Season, and with me is Andre Mon Perez. Thank you for watching.